Hi folks, welcome to day 21. Today we're going to be going through section 8.2, which is all on graphing the function y equals ax squared plus c. So last week we learned how to graph this function y equals ax squared, and I drew a general one for you in that light blue color. Now, the thing that changes the most with this added c at the end is that now what's going to happen is that our graph is either going to be moved up by c units if c is positive, or it'll move down c units if c is negative. All right, so that's the biggest change visually of what's happening is that c either moves the graph up or it moves it down. But part of what is nice visually to see is that our center point, our vertex, that doesn't change left and right. It only is changing up and down. So here's a few important pieces of information that are really essential when we're going through with these. The biggest differences, all right? So your biggest difference that you're going to see with graphing y equals ax squared plus c is that your vertex is going to change and your range is going to change. So your vertex for y equals ax squared, right? If we were looking at our original vertex, you can see it's supposed to be at 0, 0. So your vertex for y equals ax squared, what we worked on last week, was 0, 0. For y equals ax squared plus c, your vertex is always going to be at 0, c. If c is positive, then it'll be at 0, positive number. If it's negative, it'll be at 0, negative number. All right, so if you had like negative 1/2 x squared plus 2, our vertex would be at 0, 2, because 2 is our c. But if it was at, like, let's say 2x squared minus 5, then our vertex would be at 0, negative 5, because c is negative 5. All right, so that's the important part about the vertex. Your range is also changing. So your range for last week had two stipulations. If a was bigger than 0, it had something going on, and if a was smaller than 0, it had something going on. So when a was bigger than 0, y was bigger than or equal to 0. And when a was smaller than 0, y was less than or equal to 0. Now, the only difference is that instead of y being bigger or smaller than 0, you're going to have y will be bigger or smaller than c. All right? And this makes sense visually, because if we had a positive a, then it's going to be moving if we have a positive a, it's going to be opening upward like I just drew. But you can see I also have some movement down, so I have a negative c. But since a is positive, I'd say that y would be greater than or equal to whatever that c value is. Maybe that's at like negative 1. So I'd say that y is bigger than or equal to negative 1. Similarly, if we had something like this, let's say that's up 5. So this is maybe y is equal to like negative x squared minus 5. All right, plus 5. I moved up 5, but for my range, I'm still y is less than or equal to my c value. My c is 5. All right, so that would be my range for my right graph. My left graph would be y is greater than or equal to negative 1. All right, So those ones are like harder examples that I wanted to make sure I gave you, so you can see that I had a positive A with a negative C on my left example, and I had a negative A with a positive C on my right example. All right, the only difference is if C was positive in my left example, so over here, if this was positive 1, it would just be a positive 1 here. And similarly, if it had moved down 5, then we would just have a negative 5. All right. So I don't want you to get too tripped up on the range, because that's honestly the one of the easier parts. All right. So y is always greater than or equal to c if a is greater than 0, and y is always less than or equal to c if a is less than 0. All right? So let's go ahead and do one full example. And I'm going to do one that's different than what I did in the notes. So you can feel free to check out in the written notes a slightly easier example. I wanted to do a harder one with y'all because I'd rather do a harder one with you, so that way you're doing like easier ones in your examples, in your problems. All right. So for example, we're going to have y equals negative 1/3 x squared plus 6. So our c value is 6, and our a is negative 1/3. So your problems are going to ask you to graph, find the vertex, which we know is 0, c, find the axis of symmetry, which we know, all we know about the axis of symmetry right now is that it always goes through that vertex. All right, and then the domain, which remember for all quadratics, the domain is always all real numbers, and our range, which we just identified. Now I know some of you are going to be intimidated because this seems like a lot to do. But remember, we already did all of that hard stuff last week, right? We learned how to do all the hard stuff last week. The hard stuff is, all right, we have to graph it, all right? Your first step with graphing, this is still just a quadratic, so even though it looks more complicated, your first step in graphing is always making a t-chart. I'm going to always recommend that when you're working in graphs like this, you're going to want to go from -3 to +3. Only because then you get some on the positive side and the negative side of your x's, right? You're going to have negative x's and positive x's, which is what you want. Because reason you want that is because it's a symmetric function, right? The axis of symmetry divides it in 2. All right. So we have that y is equal to negative 1/3 times x squared plus 6. I'm going to let you know the biggest mistake that I've seen so far from y'all, and the biggest mistakes I saw when I taught a similar unit in advanced algebra last trimester, is that you're forgetting one of the most important things in math, and that's PEMDAS. Remember that order of operations really matters, so you want to make sure that you're always exponentiating. So you're going to always work with that squared before you multiply. So let's go ahead and let's start with y equals -3. So we have y equals negative 1/3 x squared, but my x, not y equals -3, x equals -3. So my x is now -3, so I'm going to replace that x up in my equation with a -3. So I have y equals negative 1/3 times x squared, in this case x is -3, and then plus 6. So your negative 1/3, that just hangs out up front. You don't do anything with that yet because you have to follow the order of operations. First we exponentiate, so you have -3 squared, which is -3 times -3. -3 times -3 is 9. All right? So we have y equals negative 1/3 times 9 plus 6. Well, you can always multiply your fractions by multiplying the numerators and then multiplying the denominators. So here we have 9 times 1, which is 9. Well, 9 times -1, which is -9, divided by 3 times 1, which is 3, plus 6. 9 divided by -9 divided by 3 gives us -3 plus 6. So y equals 3. Now, when we go and put that in, we can actually put that in for x equals -3 and for x equals +3. And the reason that we can do that is because here we have this -3 squared. -3 squared is the exact same thing as +3 squared. So you're going to get the same answer with positives and negatives. So feel free to use that shortcut. Let's go ahead and plug in x equals -2. So I'm going to rewrite, so I have 1/3 times x squared plus 6. So we're going to go ahead and plug in that -2 in for my x. So when I do that, I then have y equals -1/3 times -2 squared plus 6. My first step, since I'm following PEMDAS, I have to get rid of that exponent. So I'm going to first exponentiate. So when I do that exponent, I do -2 squared, which is -2 times -2, which is 4. All right, so then I have to go ahead and multiply. Again, multiply my numerators and my denominators. I'm getting -4/3 plus 6. My strong recommendation, if you have a calculator, feel free to use it. I'm not currently using a calculator because I want to show you all how to use it without a calculator. But if we wanted to have a denominator of 3 with our 6 in order to add them, then what you can do is you can multiply by 3/3. And the reason why you can do that is because 3 divided by 3 is 1. So 6 times 1 is just 6. We're just representing it differently. So 6 times 3, remember that's like 6/1 times 3/3. So 6 times 3 is 18. 3 times 1 is 3. Once we have common denominators, now we can go ahead and add them. So then you have -4/3 plus 18/3. So that's -4 plus 18/3, which would be 14/3. So we're going to go ahead and up here put in our 14/3 for both -2 and for +2. This is a fraction. It's okay to have fractions. Don't feel worried that you have fractions. Fractions are okay. You might want to write them as decimals. So in this case, 14/3 would be the same thing as like 4.67, right? So you're welcome to write them as decimals for when you're graphing because it might be easier. So I'm going to go ahead, I'll erase this and write in our 4.67. And last but not least, we have our, well, actually we have our 1s and then our 0s. So let's go ahead and plug in x equals -1. So we have -1/3 times -1 squared plus 6. -1 squared is just 1. 1 times -1/3 is just -1/3. And we know that 6 is now 18/3. So I can rewrite that as -1/3 plus 18/3 to get 17/3. Right, 17/3 would be about 5.67. If I am doing that math right. And last but not least, now we have our 0. So when you plug in x equals 0, you have y equals -1/3 times 0 squared plus 6. So that's -1/3 times 0 plus 6. -1/3 times 0 is just 0, so we have 0 plus 6, which is just 6. All right. So I have my t-chart where we have goes from -3 to +3. So what I'm going to go ahead and do is I'm going to try and bring that down with me. It might not let me, so maybe I'll just try and copy it. And what I'll do is I'm going to show you how to graph this. Alright, so I'm going to go ahead and in my toolbar change my paper to some grid paper. And I'm going to make it actually a little bit bigger grid paper. There we go. And then what I'm going to do, I know that my x's have to go from -3 to +3, and my y's have to go all the way up to 6 as a minimum. So what I will do, I'm also going to write that we're graphing -1/3 x squared plus 6. So let's go ahead. Let's see, let's make this 6, 5, 4, 3, 2, and 1. So this is on our x-axis. So I'm just going to make each box worth 1. Or each line, I should say. All right, so now that we have our t-chart, what we're going to do is we're going to go to our x value. So I'm going to go to the left to -3. Then I'm going to go up to +3, make a point. Then I'm going to go to -2 on the x, up to +4.67, roughly about there. All right. Then I'm going to go -1 and up to 5.67. So I'm going to go to the left, -1, and then up to about 5.67. All right, then I have 0, 6, 1, 5.67, 2, 4.67, and 3, 1. Now that we have all of those dots in, we can go ahead and connect them with their curve. You can see that's, roughly U-shaped. I'm a human, so I don't graph perfectly, but that's okay. And there you have it. There you have your graph. But remember, it also asked us to identify the vertex, the axis of symmetry, domain, and range. Vertex you can really easily identify right here on our graph, right? It's that spot where it's no longer increasing or decreasing, it's just there. So that vertex, remember, is always at 0, c. Our c is 6, so our vertex is at 0, 6. Our axis of symmetry always goes through that vertex, so our axis of symmetry is at x equals 0, just like when we had y equals ax squared. Our domain is always that x is all real numbers. And our range, since we have our a value is less than 0, so our y for our range is going to be less than or equal to our c value, and c is 6. Looking at that on the graph, that makes sense. Everything for the graph is below 6, so that's great. So there you have it. I know that was a little bit of a longer video, but now you have everything that you're going to need. And I also went through the hardest type of example for how to graph y equals ax squared plus c. Go ahead and try out those 4 problems for you that I have for you on Canvas, and let me know how it goes. Let me know if you have any questions. Feel free to email me. Happy to chat with you about anything you have questions about. Thanks for watching.